All right, so I just wanted to make a screencast so you could check your work in solving these combination circuits, which are a combination of parallel and series circuit. So the example we did today in class, I'll just do that one. And we had a resistor there that was 3 ohms. And then we had a resistor over here that was, what, 1 ohm. And then we had a 3 ohm and a 6 ohm in parallel. So there's a 3 ohm. And then here's a 6 ohm in parallel. So the first thing I would do is I would make a equivalent circuit. Oh yeah, and I forgot. This is 12 volts here, and this is 0 volts there. So I would draw an equivalent circuit, and I would replace the parallel branch with one resistor. So it'll look something like this. All right? And then I would draw actually a third equivalent circuit where I would replace those 3 resistors with one. All right? So there it is. Something like that. So this is 12 volts, 0 volts, 12 volts, 0 volts. And this is my 3 ohm. And this is my 1 ohm. And I need to first find, I'm going to have to find what the equivalent resistance for that branch will be. Okay? So let me do that. Since that's a parallel branch, we'll have to use 1 over R equivalent equals 1 over 3 ohms plus 1 over 6 ohms, right? And that means 1 over R equivalent equals, what's this? 2 over 6 ohms, right? Multiply the numerator and denominator by 2 plus 1 over 6 ohms. That means 1 over R equivalent is going to equal 3 over 6 ohms, right? So that means 1 over R equivalent equals 1 over 2 ohms. Well, that implies that R equivalent is just 2 ohms. So this resistor is 2 ohms, right? And then, so now I know that that's 2 ohms. So that makes this one in my final circuit. I gotta add 3. I gotta add 3, 2, and 1, right? If I add those 3 together, I get 5, 6 ohms, right? That looks a little weird. Let me fix that. There's a nice omega. And then I'll find the current, right? So let's find what this current is in this circuit. Okay, so that current, I, is going to be delta V over R. That's just Ohm's law. My delta V is, what, 12 volts over 6 ohms. So that's just 2 amps, right? So this current is 2 amps. That means this current here on this circuit is also 2 amps, right? And that'll allow me to go about finding, since I know the current now everywhere here, I can find this voltage drop right there. because I know up to there it's 12 volts, right? So this voltage drop, delta V, is just IR, right? So I is 2 amps, R is 3 ohms, so that means delta V is just 6 volts, right? So if I have 12 volts and I subtract 6, that means this wire is 6 volts, right? That means all the way to here is 6 volts. And if I look at the bottom half of the circuit, up to there is 0 volts, right? But I have for this resistor, I have the current, I have the resistance, so I can find, I have I have the current and the resistance, I can find the voltage drop there. So, I don't know where I'm writing I can find delta V, not I. So delta V is IR again. So I is 2 amps, R is 1 ohm, so my voltage drop has to be 1 volt right there. Did I do that right? No. My voltage drop has to be 2 volts right there. All right, so that tells me that this has to be 2 volts right here, which means that has to be 2 volts right there, right? So these resistors here are the same ones. So I have 12 volts up to there, and then I have to drop down to 6 volts here, right? And then I have 0 volts all the way to here, but on the wire prior to that, just like the 1 ohm, that's the 1 ohm resistor, the other side has to be 2 volts. And my voltage doesn't change at the junction, so 2 volts here, 2 volts here, 6 volts here, 6 volts here. So I pretty much have almost everything done. I'll just copy my current from my equivalent circuit here, because that current's the same. That's 2 amps, right? Now, I can find the current across here, right? Maybe that's not where I want to draw it. I don't have a lot of room right there. Let me draw it here. So I, in that section, is delta V over R. So I is going to be 6 volts over 3 ohms, right? Is that right? Okay, looks right. 6 volts over 3 ohms. So that means in that branch, what's 6 volts? 6 volts over 3 ohms. That's going to be 2 amps. Is that right? No, that's not right. That can't be right. Something's wrong. Let me just double check that. Huh. Yeah, I did something wrong. Hold on a second here. Go back a few steps. There's my error right there. 4 volts is my drop on that resistor. That's a common error people make. Glad I made that so you could see it. 4 volts divided by 3 ohms. There we go. So the current, therefore, is 4/3 amp, right? 4/3 of an amp. All right, so that's this branch. So 4/3 amps, okay? And then I want to find this current going across there, right? And to do that, I'll use Ohm's law again. Do it right here. I is delta V over R. Delta V there is also 4 volts. But now the resistance is 6 ohms. So that's just 2/3 of an amp. 2/3 amps. So that's 2/3 amps. Now, what I still haven't found yet is the power, which I can easily find at each resistor. I'll do that in red so it's easier to see. So I'll find the power there. Power is VI, delta V times I. So on that resistor, how much energy is leaving the circuit each second? The voltage drop is 6 volts, and I is 2 amps, right? Is that right? Yeah. So that means the power is 12 watts of power, 12 joules per second. That's what that means. That's 12 joules per second. Okay? So that's power. Let's do this one now over here. How much energy is leaving the circuit there? Power again, V times I. I could have also used I squared times R. That would work. Power is, so my voltage drop is 2 volts times 2 amps. That's interesting. That's 4 watts on my 1 ohm resistor. And let's find the power here. So power VI equals, so my voltage drop was 4 volts times 4/3 of an amp. 4/3 amps equals 16/3. So 16 over 3 watts. Okay. And lastly, I'll find the power here. Wow, I'm running out of space. It's getting scary. Here, I'll do it right here. Power on my, 6 ohm resistor. Still going to be VI, which is going to be 4 volts times 2/3 amps. 2/3 amps. So that's going to be, 8/3 watts. Okay? So one kind of interesting thing, right? I can also find the power right here at the battery. Power at the battery is going to be VI as well. So that's 12 volts times 2 amps. So that means power is going to be 24 watts. So sort of interesting, maybe I'll do this down below. 24 watts, right? Well, that has to equal the energy per second going into the circuit has to equal the energy per second going out of the circuit, right? And so I can add up all the others, and I should find that it'll be the same. So I got 12 watts on my first resistor plus, I don't know, maybe I'll just go around 4/3. No, that's wrong. Wait. What's my next one? There's a lot over here. Where's that one? That one's 16/3. Right? And then I can add my, what's the other one? 8/3. 8/3 watts. Plus, what's the other one? 4 watts. Now this should add up. I hope it does. 12, 13, 14, so I got 16, right? So this simplifies to 16 watts plus, let's add those. What's 8 and 16? That's 24/3. 24 over 3 watts. Well, what's 24/3? That doesn't seem right. 24/3. Did I do that right? Oh, I know what I did. Yeah. That's got to be right because 24/3 is 8. So that equals 16 watts plus 8 watts, which checks out to be 24 watts. So it's all golden. Thank God. That was worrying me. Okay. So that's all you could do with this combination circuit. You can see it gets quite messy. So you need a strategy to really arrange your work and make it neat. And when I'm grading your stuff, I'm going to be looking for you to circle your resistors when you show me how you solved it. Otherwise, I might mark it wrong by accident. Anyway, hope you're doing well and hope this helps. Have a good day.